Okay, hello everyone. Welcome to Multimodal Weekly webinars. This is a webinar series hosted by the team at 12 Labs. We've been meeting every Friday at 1:30 p.m. Pacific time for the last, I think, 22 weeks. So it's been definitely a joy, like a ritual for me to host this series, from the get-go. Here's the topics that we tend to cover each week: news research in multimodal AI and foundation models, innovative application of multimodal in different verticals, video and multimodal projects that our community members start to share, and sometimes tutorials and guides on our platform and API. In previous session of the webinars, we have a wide range of speakers from startup, research, as well as the open source community, right? Folks from talking about ritual augmented generation to LLM evaluation to medical imaging to speech recognition and even self-supervised learning, right? For video understanding, for instance. So for this webinar session today, we'll have Chinar and Theodore talking about harnessing generative AI for product and data teams. I know Chinar almost like 2 years now. Did it back in the days when I was pretty deep into like the MLOps world, and I know she's been working on her company Manot for a long time to kind of tackling different problems around computer vision. So excited to kind of see her progress, and then hearing some of the development that she was working on over the past few years. And Theodore is co-founder of PieData, and they've been working with Manot on an integration, which I'm excited to hear more about during the presentation today. So just a quick note on the logistic of the event. So feel free to send your question on Zoom chat, and we have a short Q&A session once Chinar and Theodore finish with their talk. So with that, I'll let you start sharing the screen.
Super cool. Thank you so much, James, for having us today, and thank you so much for participants. So let me share my screen. Okay. Can you see my screen?
Yeah, I see it now.
Okay, super cool. Let's do that. Awesome. Hello, everyone. Super excited to have you all here in our webinar. And again, thank you so much, James and 12 Labs, for putting this together. I'm Chinar, the CEO of Manot. Manot is an insight management platform that helps you analyze AI performance and behavior. And with our platform, we help other AI teams, engineers, product managers, to have more efficient data and model curation pipeline. So what is it? Just in 2 sentences, it proposes actionable insights in the form of images where your AI model, specifically computer vision model, will fail. And with Theo, the CEO of PieData, we're going to explore how generative AI could be used hands-on to streamline the computer vision model and data curation pipelines. And before doing this, startups, we have been in the venture-backed startups, also research labs, being part of research, engineering, and also investment. Just a background. A little bit about today's kind of agenda. So whether you are working on the product side or the development side of building and delivering computer vision models, during this session, we will review the development lifecycle, the overall computer vision development lifecycle from data collection to model serving. We will look deeper into the gaps in the current data and model curation pipelines. And most importantly, like today, generative AI is a hot topic. We will talk about generative AI as a solution, bridging this gap And by the end of it, I'll walk you through our integration, Manot plus PieData and its core features, and we'll showcase the benefits on an example, well-known example that we did. We benchmarked it on well-known, recently published facet dataset by Meta. Yeah, a little bit background about this computer vision. Well, I assume you all are coming from like computer vision AI part, like you have been there before. So picturing a world where artificial intelligence and mainly computer vision isn't just a lab experiment, but a daily companion, working wonders in our lives isn't far off. So think about our homes becoming smarter than ever, lights, temperature, and even our like coffee maker know what we want before we do. This just shows that computer vision is maturing from research lab to real world deployment, from sport analytics to healthcare to robots and self-driving cars and many more. And the question is, how reliable is the accuracy? And most importantly, what it takes to identify potential pitfalls, and how scalable are the current feel-to-good approaches. Yeah, but like any adventure, there are twists and turns. Remember the time when Tesla was mistaking the moon for a traffic light? It sounds funny, but it could have been dangerous. And with the deployment of computer vision in airports, self-driving cars, grocery stores, and home security systems, such hiccups are unacceptable. They remind us that artificial intelligence in general, but in this case, like as we focus on computer vision, while powerful, needs careful handling. And as the technology matures, a different class of security issues arises, and the question remains, how do we generalize a computer vision model to new regions and novel environments so that it never fails to distinguish between, say, a traffic light and the moon? And this problem, let's just define this problem. How this problem is connected with data collection, data preparation, model curation, data curation, like cycles. So this is a classic overview of training versus real world data. To get to the solution, first, let's try to understand what is the problem, the main problem. Well, neither Tesla nor any other company is able to avoid AI model failures, misclassification, misdetection, false positives, false negatives. As there is always a huge gap between the training data and real world scenarios, as well as the test set that we, as an engineer, we tested our model and get some 99% accuracy. And always we think how representative is this test set of the outside world, where this world changes and evolves over time, and how we can be aware of potential changes and just incorporate back to the model, test it out, and then refine the model, fix it. Having this kind of problem statement, not the problem statement, but the common life cycle that we have, one of the questions that we are having as an engineer is this pipeline. We do data preparation, data collection, then data validation, feature analysis, model training, model evaluation, and then deployment in production, like model serving. And then only then we get feedback about its performance and repeat the same cycle. Like on the left side, computer vision team is and the right side product team or engineers and customers. Sorry, managers and customers. They all are working already developed model, and they all try to tell us as an engineer what is the problem with the model. And then after having that feedback, we try to reproduce it. We try to analyze the model, the failure. And here is this like kind of feedback loop representation. So 70%, what experiments and statistics show, 70% of AI models, including computer vision models that go to production, show that there is a long feedback loop to identify failures, report it to the development side, and resolve it. So this means in the computer vision lifecycle, the long feedback loop is between the product or customer and development sides, and it takes months to refine and redeploy models. We surveyed more than 150 companies to clearly lay out the feedback loop flow. So what is happening with these like three steps? So what they do, first they identify failures. This means either wait for product managers to tell us something is wrong with the model, or use proxy signals or heuristics to approximate errors. At the very least, embrace a certain number of silent failures as an acceptable risk. Then they diagnose failures by manually analyzing the failure reports, manually classifying and labeling reported failures and reproducing them. Lastly, manually ranking and prioritizing. And finally, to refine these results to refinement cycles stretching from 2 to 4 months involving unhappy customers or end users, and stress out product managers and computer vision teams. I assume we all, like, if in the audience we have computer vision engineers or data engineers plus product managers, they all have faced these issues if they have like models in production. So we introduce a novel solution to fill this gap, Manot plus PieData. What we do? We offer a novel solution which automatically curates data and model. So as an engineer or product manager, you are able to pinpoint where the model will be failing and what is the necessary data to be added to the training data to refine the model. So before going further of these two integrations, let's just talk about Manot and then PieData. As I mentioned, with our like sophisticated algorithms, we help engineers to evaluate their models' performance without heuristics or deterministic approaches. But we are able to help you to predict potential false positives, false negatives, after you have some model which is trained on some data set, and you have a small test set that you have curated, and you need to understand what are the cases out of this test set that you need to consider to curate, to add to retraining purposes, or just be aware that the model will be failing there. And the question is how Manot does this. So PieData has 1 billion annotated images from, I'll talk about PieData in the next slide, but yeah, they have huge amount of data set. So what it does, Manot sits on top of PieData's huge data lake, and any engineer can link their like model to Manot and can curate data, and then retrain the model and redeploy it in the real world or just in production. So here, the benefit is this, that you are not going to do manual work. What you do, you just have 2 buttons, like 3 buttons, and you are able to see data, already annotated data for your specific use case. Plus, you are able to extract necessary data. It's not about just having data, but what should be there. And with this, we reduce this feedback loop. You don't need to wait for errors. You don't need to do any manual work, analysis, classification of errors, etc., etc. But both engineers and product team, they see what is happening with the model and how they can manage the data and the model in a more efficient way. This is about this overall kind of pipeline of integration. And I mentioned that Manot proposes actionable insights from PieData's 1 billion data lake. So you can refine, redeploy your model and curate the necessary data. So from the beginning of this session up to this point, I said about these actionable insights at least 7 times. So it is high time to understand what this means. So actionable insight comes in the form of an image that potentially contains false positive or false negative for your model. For example, misclassification, misdetection. It also has a failure importance score attached to it. Higher score means indicates worse performance. And plus, this image is important, has the most impact on the model refinement, like active learning stuff. And also with the image, you will get a description, caption of the failure. For example, people walking back to the camera, wearing glasses, and many more. And finally, for the most curious among you, we also have the option of prompting a specific failure. And these all coming from PieData's 1 billion images. So you can just generate these images through prompting, easily prompts. And right now about this PieData's 1 billion annotated data lake. So huge amount of data lake, realistic images already reviewed, cleaned, and you can just simply use prompts, queries, and get desired images with annotations from text to tags to polygons to bounding boxes. It depends on what kind of use case you are exploring and what kind of model and application you have. Yeah, right now I'm excited to walk you through our recent benchmarks after doing this integration with PieData. So give me a second, I'll share my the other screen. Can you see the platform screen, guys, or not?
Yeah, I can see it.
Awesome. So this is the platform kind of screen, the platform through Manot. So anyone just log in this platform, that Manot.ai, sign up there, and everyone will see this this page first. So I'll just walk you through these 3 sectors, and we will go this integration part, how it works. So what you can do, you can just create your own projects. You can have shared projects within your teams, and also you can see some public projects by us, by our engineers. The one that I'm going to showcase is this person multi-class detection on Facet dataset. Facet is a dataset that recently Meta introduced us. It contains, as far as I remember, 52 person classes and around 50K already annotated images. And they mentioned that this data is representative and everyone can use it to have not biased model for person detection purposes. And what we did with this integration, we just trained well-known, like state-of-the-art models of YOLO version 5 on the facet dataset, and we took like around 25K images from facet dataset for training purposes, and the map after the training was around like 50% on validation set, and also we select around like 3K images from facet dataset out of this training and validation sets to set up our like algorithm. What does this mean? In order to use Manot algorithm, what you need, you should provide the model performance that I mentioned over here. Give me a second. Like this part, you should provide only subset of images and the labels of that those images plus your model output on those images. This is the only input that you need to provide Manot to evaluate and get images get images outside of your test set where the model will be failing badly. So we did this experiment, and we then used PieData's 1 billion images to extract, to get insights for evaluation purposes where the model will be failing, this trained model on facet dataset. And here we can see like insights from PieData Lake, and Manot has identified around like 550 insights in the form of images where the model will be failing. And again, this is out of facet dataset. So automatically you are getting images with annotations, so you can easily add to training dataset and retrain the model. So those insights are shown here, and you also have a feature to explore it by clustering it, by generating the captions. Also, you have option here, like you have a feature of getting this scoring mechanism. A higher score means worse performance. As I mentioned, you can filter these insights by a certain degree of score that you need. Also, you can just simply prompt within these insights and use it for further analysis. This is the overall presentation, like demonstration of these insights. And you can ask like, what is my next step? Like, well, I have this model, I knew what was the accuracy of the model, and after having these images, what can I do? As a next step, you simply can check it using like some labeling tool. Like you can check the labels. Just you can directly trigger those images, these insights to your labeling tool. Right now we have an integration with Label Studio, but the platform is developed anyway, so you can easily link any like labeling tool to this to our platform. This is about like this integration, Manot plus PieData. I'll show you how you can just do create another project and get these insights through PieData data lake through just checking this box. Yeah, I guess this much from my side. I'm happy to answer any questions. This with that it will be more interactive, and yeah, thank you so much.
Right, thanks, Chinar. Thanks for the presentation. Anyone in the audience have any question about PieData, Manot, and the integration, feel free to unmute and you can ask the question. Yeah, I guess like maybe one from my end is how do you think data labeling tools
how they are integrating labeling tools?
I guess my question is more like sort of the role of data labeling in the age of Gen AI, right? Yeah, we see a lot of with the rise of, say, large language model, right? You see the power of like pre-trained model that doesn't require a lot of supervision, and I assume that can also be in the case of computer vision, where you like practitioners going to start using like pre-trained model for computer vision, right? That has been like pre-trained on like billions of images, for instance. And as a result, that model can perform very well for downstream tasks, and that sort of limit, reduce the need for label data, right? So do you think like in that scenario, do you think data labeling still going to be necessary? Or what do you think about the role of the labeling solution, in the setting?
Okay, got you. So yeah, thank you so much, James, for the question. What I can tell you about this, so hopefully we will have another like foundation, like multimodal really soon for like computer vision plus like ChatGPT. And with that, there will be a lot of like use cases that engineers will like do some custom retraining. For example, ChatGPT for enterprises, they take it, they use APIs, they do some fine tuning on there, some data set, like internal data set, custom data set, and then they use it for further tasks. And the question is, after doing that, how well, first how they prepare that data, and then how they continue curating more data. Because again, you can fine tune a huge model, but still it's going to have problems, pitfalls. Like we see that with these huge LLMs. Those LLMs like ChatGPT or other like large language models, they hallucinate. Like these models hallucinate. So how we are going to cover, like bridge that gap? So again, here we are going to have some sort of problems of correct data curation plus labeling, relabeling, or correcting already annotated data.
So I guess the main point here, like even though this foundation model is going to be pretty powerful, there's still a definite need for curating label data in order to make sure that foundation model for the downstream task, right?
Yeah, that's my kind of bet while talking to like the industry experts, other companies, what I see, like, and the example of ChatGPT says that like it proves that, because again, we need like here we have a term right now, it's pretty like common term right now. They say like reinforcement learning with human feedback. So again, like you should curate data, you should curate model, and human in the loop. And with this, we should have a platform that kind of automates this feedback loop pipeline.
We'll see. So basically, data labeling in the age of Gen AI is RLHF, right? So it's not that much difference. Yeah. Any other question from the audience? Maybe like one or two more, and in this scenario, there's no question. we can probably annually, but maybe I want to follow up on my previous point, right? So, you start the company back during the days of like, traditional machine learning, right? And now like the whole field kind of transition into like the age of large model. And so it's a very different, like, I guess the perception of AI has changed a lot. Like for you as a startup founder in the space, like, how do you navigate this transition, like, to like when building your product, right? How did you navigate the transition of like enthusiasm and interest for AI in order to like capture some of the demand, right? That the public has for the industry.
Yeah, that's a good question. In fact, yeah, if we compare the situation last year, October, November, and right now, really different, and trends are really different. What I see, like these foundation models, everything, it's growing so fast, like exponentially. And the next and the challenges are different, but still, as the applications are the same, and plus there are kind of problems that are being explored really easily right now, like a lot of solutions through these foundation models. But again, like traditional AI kind of is a backbone of this overall like foundation models. What I feel, right now we try to kind of use traditional these huge models, LLMs or multi models, and do the same, like solve the same problems, but with this. So this is kind of the mapping part before and after. But again, like with this, like problem, traditional AI problem, and huge LLMs, still problems are the same. Again, fine tuning, again, feedback loop, again, like there are problems that are really common for these two kind of cases. But again, like the direction has changed a lot. Like right now we can see like people, they utilize foundation models really, really well. Like everywhere you can see the usage, new usage, and this is just a start, I mean.
Gotcha. So the main point is like same problem, but we have a new solution to tackle this problem, right?
Yeah.
Perfect. I guess one last question that I have for you is, I think your background was more from the research side of thing, right? So you, if I'm correct, you was a professor in in Armenia, right? And then you kind of like start your startup and kind of move to the States to create a company. So maybe tell the audience a little bit more about that journey transition and kind of moving from like background into like starting a company, challenges and things that you learn along the way. Yeah.
Sure. Yeah, happy to share that. Well, to be honest, like I really like this research part, curiosity in research, engineering, how AI could be helpful in general for different real world applications like healthcare or like media or robotics, everywhere. The question was that before, when I was working as an engineer, as a researcher, and while working as an engineer, the problems that I mentioned were, during my talk, model curation, data curation, curation, the feedback loop, analysis of the models, making sure that the models are working as we expect, like how to reduce this manual work. Like this was kind of my challenge. That's why I wanted to start something to kind of develop some sophisticated algorithms to help other engineers and also, like as I mentioned, like product managers are facing these issues as well, them to streamline their daily work in terms of model evaluation, also making sure that the models are performing well. Because like the Tesla example is really powerful. Like if Tesla has this problem, there are a lot of cases that the problem for sure exists. And the question is how we can like make sure that we are on track and we can like, while scaling up these like model usage, computer vision usage, we are on track to automate the overall like refinement and then redeployment part, which is really important.
Yeah, thanks for sharing that insight and how kind of that inspiration from your research they influence your influence the problem that you're trying to solve with your company. Perfect. With that, I think if there's not any other question, we probably can end the webinar a bit early. Thanks for folks for attending today. As usual, we'll run this webinar series on a weekly basis. So stay tuned for next week for future session. And I'll share the recording of this call probably in like 2-3 weeks when it becomes available on YouTube. Yeah, thanks, Chinar. Thanks for the talk, and I hope everyone enjoy the rest of your Friday.
Thank you so much, and have a great weekend ahead. And let me know if you have any questions. Just I'm available on LinkedIn. Just DM me. Thank you. Have a great one.